We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
Question number 1 for the month of October. What kind of oil does a CO2 compressor take that's on a Bitzer rack? Let me know. Send your answer to arpgiveaways@gmail.com and keep listening for more questions. Thank you.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
All right, guys, welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass, and today we're going to talk about how to prevent repeated compressor failures after they've been replaced or you're on a site where there's been multiple compressor failures. So today we're going to go over on some tips and tricks after install, what I do to keep these compressors from failing. So first and foremost, guys, compressors don't just go bad. They're usually murdered. So this is one thing to look out for. You know, if you're changing a compressor, there's a reason it failed. I mean, yeah, there is that occasional, old age. It's worn out, it's had a hard life and it finally went. But the majority of these compressors are murdered. Either by poor system performance, dirty systems, heat. So there's a reason this compressor failed. So the days of just slapping in a compressor and just walking away need to go away. Now, I feel this is more like the common on the rack refrigeration side of things because we generally have more capacity. So you lose a compressor, the guy on call, usually if he's on call, usually valves it off. It never really gets checked into, and it gets quoted. Guy comes back, slaps a compressor in, figures the last guy, looked at why the compressor died, and next thing you know, a couple days later, a couple weeks later, a month later, this compressor's dead again, because the original failure wasn't caught during the commissioning portion of the compressor startup and or the original service call. So, guys, this is where everybody needs to be a little bit more diligent with this stuff, especially now with how hard it is to even get compressors. So this is when I'm going through and, say we're going to start from when I condemn a compressor. So when I condemn a compressor, if it's in the middle of the night, I'm not ripping the heads off of it. I'm not tearing it down. I'm going to come back and do it, or I'm going to write up that it needs to get done on the initial teardown. But on the initial service call, you need to be as thorough as possible, to write up everything that is needed for that compressor change out. So say like if you're looking at this thing and the oil is just pitch black. So that's one thing. I'm like, okay, the oil is completely black in this rack. We need to, take it and we need to, clean up this oil. It's a huge problem. So like if you see a compressor failure and the oil's black and metallic, that, okay, we got metal in the oil. The compressor probably broke apart and there's metal in the oil. I mean, may have not been what killed the compressor, but it may have led to its untimely demise. So, going through stuff like that, or like looking, okay, the contactor's welded in. Did the contactor weld in because the compressor, failed, or was the contactor the failure point? So I see a lot of guys, okay, yeah, the contactor welded in, that's what killed the compressor. Well, in all reality, it was the stator dropping onto the rotor, or the rotor dropping onto the stator, and it shorted out and then caused the contactor to explode. So, I mean, it was a mechanical failure that was masked as an electrical failure. The majority of electrical failures, especially shorts on compressors, are mechanical failures. I mean, they're broken rods, broken cranks. I mean, they're drop stators or drop rotors into stators, damage like that, damaged windings. So, I mean, the majority of electrical failures are mechanical failures. That is why it's important to tear these things down. So, I mean, if it's in the middle of the daytime, not on a Friday, I'm going to rip the heads off this compressor and I'm going to inspect it. I'm going to make sure the pistons all go up and down. I'm going to see if there's any scoring on the walls. I'm going to see if it looks like it ran with liquid refrigerant in it and it scored up the walls of the compressor. So, I mean, if it had no lubrication. So, I mean, if all else fails and it, it runs good it moves good and moves free and all the pistons move up and down, you don't have a broken crank, you don't have broken rods and they're not coming past top dead center, then look at the valve plates. I mean, do we have smashed up valves? I mean, smashed up valves are, an indication of either a mechanical failure, meaning the piston came in contact with it, or the actual liquid refrigerant smashed the valves or oil smashed the valves. I mean, valve failures are generally three things. A mechanical failure in the compressor, where the piston came up too high, the liquid refrigerant entered the cylinder, or oil entered the cylinder. Too much oil, it can't compress. It can't compress a liquid, so the valve plates are the weakest things. They're going to go hopefully before the rod bends or completely shatters a piston. So that's why to actually check this stuff out is super important, because if you open a compressor up and the heads are full of oil, you have an oil issue. You have oil carrying over from the rack and making its way back down the system. So, I mean, you need to start looking at the oil system. And if you see all kinds of scarring on the cylinder walls and there's nothing inside the piston, I mean, that could very well be liquid refrigerant, washing away the oil and the piston's dragging on there. If you don't see anything in there and it's got low oil pressure, I mean, pull the oil pump out. Look at the main bearing. See how scarred up the main bearing is in the crank. That's incredibly important. I mean, was this thing not getting good lubrication? Was it getting liquid in the oil? and causing it to, clean off all the oil on all the bearing surfaces and cause the compressor to fail. So, I mean, that's why this initial diagnosis is the most important, so you could document it and quote it properly. Because if you just write up a compressor and a contactor and, two guys show up to change this compressor and contactor, and now they got to come back and say, oh, yeah, the oil's trash in the rack, there's flood back, the oil separator's blown, filter's blown, and it's not separating oil properly, and that's why the compressor died. The customer's more reluctant to do that than just to quote it properly on the first time. Now, I'm very diligent when it comes to the oil system. I mean, if the oil system isn't working properly, I mean, you're going to have oil carryover. Say the oil float's stuck closed. I mean, and you're just carrying that oil right out of the bottom of the oil separator right back into the system. Now, this is where you start getting oil return issues. Old guy told me a long time ago, stop trying to chase the oil in the store. Figure out why it's leaving the rack. It shouldn't be leaving the rack. Obviously you're going to have some oil leave the rack and go into the store. It's impossible to catch it all. No oil separator is 100% efficient. So this is where you guys need to be diligent about making sure this oil separator is separating properly. And if you have blown valves and you have an older style impingement screen oil separator and your valve plates are gone, they're inside the separator. They more than likely tore the screen in the separator. So if I have blown valve plates or pieces of pistons that are like gone, that stuff went somewhere, went down the discharge line and into the oil separator, and generally tears the sock on the oil separator. So my personal thing is, if I have blown valve plates and say I just changed valve plates, I'm going to check the oil separator, make sure it's functioning properly, and I'm going to pull it, and I'm going to see if the screen's torn. If the screen's torn, it's getting replaced with a centrifugal or a filtered type oil separator. I'm not going to put a sock back in there. I mean, I don't know how some guys get their hands up in there. Like it's almost, I tried it once. It was impossible for me. But I'm going to staple the separator back together for now. So this is the screen, the separator, so that I could get everything back functional. Because if you have a gaping hole in there, the size of your thumb, now you're losing all that oil through that hole. It's not properly screening that oil. So it's not properly screening that oil and separating all that oil properly. Now you get this vicious cycle. Now you're endangering other compressors, because now that oil is not staying at the rack, it's getting carried out to the system. It's in your liquid lines, it's in your evaporators, and then after defrost, it's going to come back and it's going to end up smashing more valve plates. So, I mean, one valve plate can, end up, messing it up for the rest of the rack. So that's why, it's imperative that you guys check over these oil systems. Make sure the filters aren't blown on coalescent type setups. If you're changing a compressor on a coalescent type setup, you should be changing the filter without a doubt. 100% without a doubt. That is, 101 proper technique in order to keep that rack clean and keep everything, functioning properly. Because if you have dirty oil and you have a dirty system, I mean, and you're putting a brand new compressor in there, all you're doing is introducing all that dirty oil right to the compressor. And then same thing with checking safeties. So every single safety needs to be verified on that compressor. So the oil safety, we need to check it, make sure it actually shuts off in a low oil condition. So what I'll do generally is I'll shut the breaker off as long as it doesn't have a current sensing relay. I'll go over that in a second. I'll shut the breaker off and make sure it times out. It doesn't see the compressor running. It should time out and it should stop that compressor. I mean, I don't know how many old oil controls I found that, either are jumped out, somebody jumped them out, there was an issue, somebody jumped them out, and now the compressor's dead, or, they just don't function properly anymore. The heater burned out of the old Johnson controls, or it's an old Centronic that is just beat up and it's been vibrating for 15 years and now it doesn't function properly. Well, I mean, if you just slap that compressor in there and don't test it, guess what? As soon as the compressor runs out of oil again, or there's an oil issue on the rack, that thing's going to be the first one dead because it doesn't shut off. So it's just going to keep running until it burns itself up. Oh, what $300 control is going to, kill a $4,000 or $5,000 compressor. So that's why it's imperative to make sure like these controls all function properly. Now, if you have one with a current sensing relay, my best advice to you would be to just jump out the relay, so you can test the oil control, so you can shut off the power to the compressor and test the oil control. That way that oil control functions properly. High pressure switches, same thing. I'll throttle them a discharge, make sure the high pressure switch actually works and it doesn't keep the compressor, running at a super high discharge pressure, and or it doesn't short cycle the compressor if it's an automatic reset. I've seen this before where it'll just short cycle the compressor. It resets like 10 or 15 pounds instead of being 50 pounds. Or it's tripping too early and it's just nonstop machine gunning the compressor till the contactor wears out and then welds in, and now the compressor single phases or something explodes a breaker. So this is why it's imperative you actually check these controls, make sure they shut off what they should be. And then on a single unit, make sure they pump down. Make sure the unit pumps down on low pressure, shuts off, goes through a defrost, pumps down completely, doesn't short cycle, doesn't high head while it's trying to pump down. I mean, there's been lots of instances where, especially single units, they get put in with a liquid line solenoid up the unit, the case is 100 feet away, and they try to pump back all that liquid, and the receiver's not big enough. It's just short cycling, and it eventually kills the compressor because every time it goes to pump down, it's high heading. So what you want to do is try to keep that from happening, a suction stop or some other means of control for defrost. And then also make sure that when this thing is defrosting, when you're actually defrosting, make sure that everything is functioning properly, and it's actually defrosting the proper way. So just make sure that it physically pumps down, it doesn't high head, it goes through defrost, and it comes back, and make sure that it's not going to overamp after it comes back out of defrost. Just make sure that when it comes back out of defrost, it's not going to overamp, it's not going to run too high of a pressure on the suction. Maybe it needs a CPR valve or some MOP power heads in there, something to keep it from overamping the suction. So that's one thing on single units, is that verify the unit functions completely. Don't just slap the compressor in, say it's a freezer. Okay, it may take almost all day for this thing to pull down by the time it pulls the concrete down, especially if it's been dead for a while. So I'll generally get it close, and then I'll throw in a defrost. I'll check it out, make sure all the heaters amp out, make sure the drain heater works, make sure all the heaters are good, make sure the fan delay works properly, and then I will turn this thing back on and make sure it doesn't overamp, and make sure it pumped down completely, because I see a lot of guys, I see repeated failures with this. They'll throw a freezer compressor in and it'll get down to 20 degrees and they'll boogie. They got other calls to run, but they didn't check its operation to make sure it functions and properly pumps down, and the low pressure switch is bad, and it just keeps going, running in a vacuum until it blows up. Now, the other caveat to this is on the discharge side of it. So high discharge temps probably kill more compressors than anything. So one thing, guys, we need to really pay attention to is discharge temps. So especially on racks, start checking discharge temps of compressors on PMs. If you start seeing compressors with higher discharge temps, than others, those compressors probably have an issue. Either the suction return gas is warmer on those, or their oil float's bleeding through and they're getting some discharge vapor in there, or something's causing that compressor to run a higher discharge temp. Bad valve plates, more load. So that's why it needs to be thoroughly checked out. Now, I'm a big proponent of this Copeland app. The Copeland app has all the COP charts loaded in there. So you could use the Copeland mobile app, type in your discharge pressure, your suction pressure, and then your suction temp, and it'll spit out what your discharge temp should be within a few degrees. Now, the way it does this is it uses the COP charts. It's looking at the compression ratio, the heat of compression, and it tells you what your discharge line temp should be. If your discharge line temp is way higher than what it says, there's an issue with that compressor, meaning there's some kind of heat getting in there. A lot of times I see failed oil floats. I see oil floats that are constantly feeding oil into the compressor, and it's constantly hot. So that's why you don't ever want to have compressors that are full to the top. I mean, you need to check those oil floats, grab it with your hand, especially if it's a high pressure system, grab it with your hand and see if that oil float is smoking hot. If it's smoking hot, then you know that you're feeding oil into that compressor when it shouldn't. So with low pressure, it's a little more difficult, but that compressor is also going to end up getting killed because it's going to overfill with oil, and that crank's smacking the oil. Eventually, that's going to break the crank. You know, you figure something rotating 3,500 RPMs around, it's hitting a surface. Well, oil and water is like concrete when you hit it that hard. So, you know, it's going to eventually cause something to break. So that's one thing you want to make sure that the oil levels are proper. You know, they're not overfilling, they're not underfilling. So you want to make sure you're not injecting in there. But then also you want to make sure the liquid injection works. So if you have Y1037 valves, you know, say you're on compound cooling racks and you have Y1037 valves, even if it's not hot enough to use it, test it. You know, get a heat gun. You know, warm up the bulb a little bit. I see these bulbs break all the time because they're not exactly run the best, and the way the rack's designed, it's kind of hard to make the bulb, you know, not vibrate. So, I mean, the bulbs end up breaking a lot, and I see a lot of, compound compressors where the Y10s don't work, and the compressors are just overheating on the interstage. There's no desuperheating valve on there. So the Y valves need to be, you know, tested. So the easiest way to do it, if a discharge temp's too low, is just take a heat gun and run it up and down there a little bit, you know, get it warmed up, you know, get it up to, you know, whatever the discharge should be, put a temp sensor right there, and just keep the heat gun moving, and it should start feeding. If it doesn't start feeding, take the bulb off, heat it up with a heat gun big time, see if it starts feeding. If it doesn't, the bulb's probably dead, or the liquid dryer's plugged up feeding it. And you could just change the bulb on these, you know, get a new valve, take the power head off, and just screw the power head on. You generally don't have to burn it out. It's just 2 pins and an orifice and a power head, so there's not really much to go wrong with the valve body itself. It's usually just the power head that breaks. You know, so change out the power head. You know, you do that, and you do a couple of these, and you would be surprised how much the discharge temps in the rack come down, you know, as a whole, because you're fixing the liquid injection and bringing down the superheat on the actual rack. So it brings down the discharge superheat, so everything starts, you know, functioning better. The condenser's bigger now because it has less discharge temp, you know, to de-superheat. So, I mean, little things like this make big impacts on the system. You know, and then making sure the vapor injection, if you have vapor injected compressors, is working. So like compound compressors, making sure that the subcooler is functioning properly and not flooding back. I see a lot of compressors get killed because the interstage floods back, whether it be a Sporlan superheat controller with a bad temp sensor, wrong refrigerant in the controls, or you say you have OEM controls, like you're controlling it and you just bad superheat settings, burned up EEVs or TXVs not set properly, and you start flooding back on the interstage. Well, that's going directly into the heads of a compressor or the inner scroll of a compressor. So if you start flooding back on that, I mean, you're going to bust valve plates big time. So I see a lot of compound compressors, valve plates get busted because of subcooler issues. And then I see guys valve the subcoolers off, and then that's another issue because that's setting your interstage pressure. And that's also, affecting your superheat at the rack. So it's going to raise your discharge temp because now that interstage is not at 40 degrees or 50 degrees, it's at like 80 or 90 degrees. So that's going to increase your discharge temps. So once you increase your discharge temps, now your condenser's smaller. So now your condenser can't keep up. So that's one thing to keep in mind. And then scrolls, same thing. You want to make sure that you're not having liquid come in the interstage of the scroll, because if you're having liquid come in the interstage of the scroll, you're going to have broken scroll plates, oil issues. I have seen scrolls pump straight liquid through the economizer line, and I'm talking like they sound like weed whackers. And usually it's a subcooler issue, and what'll happen is it'll wash all the oil out of the oil separator, and you'll actually have liquid in the discharge. Telltale sign for that is if you start having oil issues and you go up there and your subcooler looks like it's working, but your discharge temps are low, like 120, 100 degrees, like you probably have liquid moving through the economizer line. So And if you have oil fails on top of that, you definitely probably have liquid moving through there. So, I mean, you can go through there. Sometimes it won't frost, guys. I mean, if that EPR is set at 50 degrees and it's putting pure liquid in there, you're not going to have frost at a 50-degree EPR or a 40-degree EPR. So you could flood back without having frost. It's why it's so imperative to check superheat. So you need to physically make sure that there's no flood back on there. Check the superheat on there. Just because it has no frost on it doesn't mean anything. It could be chugging straight liquid through that economizer line and cause failures. Digital compressors. So the digital scrolls. I see a ton of these fail because guys will replace them and say the original, say it's a protocol, and the original unloader was into the suction header and not into the head of the compressor. And these guys just reuse the unloader solenoid coil or the unloader solenoid, and generally a lot of times they stick. And when they stick, it ends up basically separating the scroll plates all the time, and the compressor just runs and overheats until it's dead. So always on a digital scroll, change the solenoid and repipe it to the actual proper way that the Copeland has it now, where it comes off the suction and then it goes to the top of that scroll plate on the head. So you want to change that. Do not reuse the solenoid coil that's in there. And then verify when you order this that it does come with it, because I've seen it hit or miss. Some racks come with it, some racks don't come with it. So you need to verify that that scroll is that scroll compressor is actually coming with the solenoid kit. And if not, you need to order it, because somebody will go to change it and they won't have the solenoid kit, and then they just wasted a bunch of labor, because generally you got to pull this thing back out to do it, because there's usually no room to braze one in. Digital compressors. I mean, guys, if you see OMBs stuck or failed, you got to remember that's the only oil control it has. So, I mean, with OMBs, if the oil's black, that magnet and the switch inside of it is probably all plugged up. So it's really not reliable at that point. So you need to pull them apart and clean them. So take them off, take brake cleaner, you'll flush them out real good. Make sure they're good. Make sure they function properly. So what I'll generally do on a PM is I'll shut the oil line off. And
hey guys, today's episode is sponsored by Westermeyer Industries serviceable oil floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Hello guys, this episode is brought to you by Fieldpiece. The tough wireless vacuum gauge MG44 from Fieldpiece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles. Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode.
Starve all the compressors for oil, and I'll watch them. Once they get low, they should start, fill a couple times, and they should lock out. And if they don't, then I'll look at that one compressor and, I'll leave the oil line valve off and see how low it gets and see if it doesn't lock out. I see a lot of guys miss this on PMs and or checking compressors. A bad OMB could kill a compressor easy. There's no oil switches on these. So that is your only oil failure. So there's no oil pump on the scroll. So if you don't have that OMB working properly, you're going to lose oil. And then a lot of times on these protocols, guys, the high pressure switches, they're very cheap Robert Shaw, like high pressure switches. And what happens over time is you start to be able to move the plastic top of it. If you see where the pressure switch is, goes down to the 1/4-inch adapter, you got the brass and then you got the plastic on top. And then you got your 2 spade fittings. You start to be able to move that plastic, and what happens is it makes a bad connection, and it'll start machine gunning contactors. If you see contactors machine gunning, probably 8 out of 10 times, it's the high pressure switch causing it. So what happens is it starts to fail, and then it starts to have bad contacts, and it starts machine gunning contactors until it blows a contactor up. I mean, it may start that compressor 10 times in a minute. So, you're just adding starts to that. And then same thing, guys, making sure that the EMS is programmed properly and the digital compressor is programmed properly. I still, to this day, see OEMs sending out rack programs with 0 to 10 volts for like digital scrolls instead of 1 to 5. So make sure it's actually programmed properly. That compressor, I see them get written up all the time, and it's a bad IDCM. Or it's got the wrong voltage in there. Make sure that thing is programmed properly to that rack, and make sure that IDCM is wired properly and working properly. If you get motor protector trips, generally that's for overamping, or you get a switched leg. Generally somebody changed a contactor and they switched the leg around on you. So then that's a diagnostic tool, but it's not 100% accurate. Just like if it goes off on overamping, it doesn't have the set amps for that compressor in there. It just has a max threshold that those scrolls should pull. So that's one thing to just keep in mind, guys. Before you condemn a compressor or look at it, make sure that IDCM is functioning properly. Make sure that it's giving out the voltage, and you don't need to order an IDCM when you change the compressor. So that's another big thing. And then with those compressors especially, make sure that solenoid isn't stuck, because I've seen that solenoid kill more compressors than anything. And then if you look in there and that oil's black and the rest of the compressors, don't just slap that digital in and not get that oil cleaned up. If you don't clean up that oil, you're going to have another compressor fail. You're going to have another failure, whether it be from the oil eating up the bearings, or it's going to be from metal shavings. So what I'll generally do is, new rack cores, I'll throw the Sporlan extra filter that goes in the new liquid core cartridges in there. That thing cleans up racks really good. New suction cores, and then SF283 oil filters, suction filters for oil filters. I'll do those a couple times because they're a lot cheaper than an OF303, and they seem to catch a lot of the bigger, the smaller stuff a little better at first. And then I'll throw an OF303 in after everything's done and cleanup's done. So the SF283s are generally cheaper and easier to get right now. Some of the OF stuff has been kind of harder to get. So SF283s are a good alternative. Hussmann sent them out in racks for years. And then they finally started switching over to the OF303s. So after you get the cleanup done, it's imperative that you get the rack cleaned up, do a couple oil changes if you need to, flush out the oil, get everything cleaned up, put a couple gallons of fresh POE in there, and get the protocol cleaned up. Clean the valves up, figure out what's going on, check your discharge temps. I don't like to see discharge temps over 200 degrees. You start seeing stuff over 200 degrees, with 407A, 407F, 448's not as bad, but you're going to have discharge temps that high. But try to get them down. If you're superheated, the rack's high, it's going to cause high discharge temps. Or if you have, say, an oil float stuck, on the oil separator and it's just dumping hot gas in the rack into the suction header, that's increasing your superheat. So you need to fix that problem. Yeah, it's stuck open. Thank God it's stuck open and not closed, but eventually that's going to cause the superheat to increase in the rack. So that's where like checking the discharge temps comes in. That's where it's going to give you that baseline of what everything should be. If you start getting discharge temps 230, 240, 6 inches off the compressor, you're cooking that oil. Whether it's POE, mineral, you're cooking that oil. If it's mineral oil, it's going to be 10 times worse. So keep the discharge temps down, keep the compressors from failing. They say the majority of compressors fail from high discharge temps. And if you pull a head off a compressor and you look at it and it's, the valve plates are all coppered looking, that is a telltale sign of acid and water in the rack, because that's called copper plating. Copper plating will get on all the surfaces, bearings, valve plates, you name it, and it will start to mess up the tolerances because now it won't seal properly because that copper plating is there and causing everything not to seal properly. So that's why it's imperative that if you do have that, you start an acid cleanup on the rack. Start putting acid cores in, put some liquid cores in the suction that are acid rated, so that way all that suction return gas and oil can go through those cores and get cleaned up. Do an oil change on the rack. You got to get that oil out of there because the majority of that water is sitting in that oil. So it's harder to get the water out of the oil using filters. So dump the oil, fresh oil in, it's clean and it's not acidic. So do it a couple times till you get that oil, that acid level down, and then send out your oil, to have it tested at a professional lab to tell you what your moisture percentage is. It may take you a while to clean up that rack, but that water got in there somehow. So is it bad service, procedures, or is the rack running in a vacuum at times, or is the liquid lines or the main low pressure switch in the rack not working and it's letting things run in a vacuum when it's in switchback? I mean, that's stuff that needs to get checked. I mean, we had that situation at the store. The low pressure switch or the transistor failed. The building controls monitoring people forced the rack transducer. All the compressors were running. Cases were making temp, cycling off, and the low pressure switch was bad at the rack, and it was just running all the compressors all the time. The thing was running like a 3-4 inch vacuum, and the damage was done at that point. The sight glass was yellow. We had valves locking up every couple days. We had to dump hot water on them. It took us a straight month to get this rack cleaned up. With putting liquid cores, acid cores in, moisture cores, cores in the liquid lines, changing the oil a couple times to get the moisture down to like a acceptable level to where we could start, combating it, monthly, not every single day. It took us a long time to get it cleaned up, but all over a bad low pressure switch. So that's, some things you guys just got to keep in mind. That's why it's imperative when you're changing these compressors to go through the whole rack and make sure everything's functioning properly. Do you have flood back at random times? After a defrost, are you coming back to the rack hard? I see this a lot at stores where big POS coils, and they have 2 suction stop valves. They have a small valve and a big valve. So the small valve is to pump the coil out, generally like a 1/2 inch or 5/8 valve. And what you do with that is you're energizing that valve first for a set amount of time. So say when it calls for refrigeration again, it's going to say for 5 minutes, I'm going to pump this coil out with the small valve. So what this does is 2 things. It doesn't overload the rack and bring on a bunch of compressors, and it pumps out the coil. So if there is any liquid in there, it's a small amount coming back through a 5/8 solenoid instead of a 2 1/8 solenoid and causing compressors to break. So it's more controlled through a 5/8 solenoid. I see these not functioning, bad time delays, or jumped out all the time. So then you have this 2 1/8 valve kicking in, and now you have this coil that was full of cool gas defrost, or it was off time and there's a ton of liquid in there. It's just all rushing back to the rack at once, and it's just blowing apart valve plates or compressors. So this is a big thing. Make sure that pump out system functions properly. after defrost, it's a huge load. So if you're graphing out the suction temperature on the rack and you see, okay, I see a spike way down, say the suction saturation is supposed to be 20 degrees. We're running a constant 40, 45 degrees, 25 degrees of superheat. Rack looks good. Then all of a sudden, it just dips right down to like 20 degrees and then dips up. And then it does it again, 20 degrees, dips up. Well, if you overlay the defrost times, you could probably figure out which one is causing that. And repair that issue, fix the defrost termination, fix the defrost times, fix the pump out, whatever it is. I mean, that goes for smaller stuff too. It doesn't take a very big coil to load up with liquid and wash a rack out. So that's why it's imperative to check those suction temps, make sure there's not random flood back on this rack. Just because it kills one compressor on the rack every single time doesn't mean that. It's just the way that the header's piped. Maybe that compressor is a little bit lower in the header and it's getting more oil and liquid into it. Maybe it's the way they drilled the pickup tube inside of it. It's, getting more liquid and oil. So, I mean, keep trying to figure out why that compressor keeps dying. Figure out what's killing that compressor and take that out of the equation. So, I mean, I've ripped apart headers before to try to see, what the issue was, why one compressor kept dying, and it ended up being the oil separator was trashed. So we kept trying to figure out why this one compressor kept getting killed with oil. It kept getting slugged and slugged and slugged. Well, in all reality, the oil separator was trashed, and if we just kept the oil at the rack and fixed that, then we wouldn't have this compressor that kept getting oil coming back down to it. It just depends on how the way the rack's piped. Let's just be honest. None of this field piping is, perfect. None of it's, 100% to spec. It just never is that way. So, if you keep the liquid out of the compressors, if you keep the oil at the rack, these compressors are going to be they're going to end up lasting way longer. So, I'm not a big fan of changing compressors, so I will spend more time to properly diagnose this than to change it again. Some compressor manufacturers are a little more lenient on it. Like Copeland, in 12 years, I've seen them deny 2 warranty compressors. Bitzer is like every other one. So, I mean, yeah, if you throw this compressor in here and the customer says, well, that compressor's under warranty. So, okay, so we go order the warranty compressor and now you're getting hosed with a compressor because guess what? It's under warranty and the OEM denies it, 6 months later and you're on the hook for a compressor, for the second compressor. So this is why you guys want to try to avoid this. Like it's, nobody wants to get a bill for $5,000 that the customer's not going to pay, 6 months later after the work order's closed out and everything else is done and the contractor gets hosed. They're the only one that gets hosed. But if they would have done their due diligence and checked it out, then yeah. But also on that note, I do not condone buying rebuilt compressors. Every time I get a rebuilt compressor, it generally fails. Especially from one OEM that I'm not, or one manufacturer, I'm not going to name names, but everybody knows who it is. They are quite shady about it. And, when they get a compressor in, they figure out why it failed. They say they tear it down, but I've seen some of the insides of these compressors, and I had one run for 5 minutes one day. We slapped it in, turned it on, ran for 5 minutes. The second time we went to go cycle on, it was pulling 120 amps and tripping a breaker. Broken rod. Either they didn't put a rod cap on all the way, or the crank was messed up. But same thing, like this is the third rebuilt compressor in its place, and the first two didn't even make it 10 hours. We put an OEM compressor in there. 0 issues. Compressor still running to this day. So you get what you pay for in the end. I mean, there's a reason, rebuilt compressors are from these rebuilders are, a couple $1,000 cheaper than an OEM compressor. With that OEM compressor, you're getting a completely rebuilt compressor from the ground up. Copeland or Carlisle strips them all the way down, redoes everything, new motors, new cranks, everything. They get reconditioned. They aren't just fixing whatever's wrong with them, slapping new paint on them and sending them out the door. They're actually, physically going through them, and you're getting a properly redone compressor. So that's why I'm a big proponent of just buying the right compressor to begin with. I cannot stand changing, non-OEM compressors. There's be times where customers, buy this, and that's where it becomes an issue. And then same thing when you guys are dealing with in-house stuff. Like I see this all the time. We get contracted to change a compressor in an in-house. It goes out to bid. 3 contractors bid on it, and one company gets it. Just watch with this, because I've seen these in-house companies screw guys, because the in-house guy says, okay, yeah, I need this compressor changed. Don't worry about it. I already looked at it. Okay, company slaps it in, puts the compressor in. It's dead 3 days later. Who do you think the customer's mad at? You think they're mad at their own store tech? Nope. Store tech's going to push it off on you. It's going to say, you guys did something wrong, yada, yada, yada. So I always check it over, even if it's this store tech, condemned it. I'll pull the heads off the compressor. It doesn't take you more than 10 minutes to pull the heads off the compressor. Buzz all the bolts off an impact, break it loose. Just look at the heads. Are the valve plates blown? Are the pistons messed up? Did they all move? Is this compressor actually bad? Check it over. Like every compressor that I condemn or I change, if it's a semi-aromatic, it's getting the heads pulled and it's getting inspected. Plain and simple. Because it's going to take me 10 minutes. I'm going to get a brief overview of what happened to it, so I could try to avoid doing it. If you're not pulling the heads, you're doing yourself and the customer a disservice, because it's going to fail again. I mean, the OEMs, even if it's under warranty, the OEMs are never going to say anything about you pulling the heads. I mean, I think they would rather you pull the heads and figure out why it failed, instead of them eating another compressor. So that's why it's imperative to pull these things apart and see why they failed. So that way you're not changing another compressor, or why it failed. So same thing with like the in-house guys. Like I don't care what that in-house guy did. I don't care, whatever it is. I'm going to look through the system, make sure that the thing's not going to fail. And if you do find something, bring it to their attention. I mean, I'm sure they would rather, bring that to their attention than have another compressor fail. And then it starts this finger pointing contest. I'm not a big fan of this. So I would rather just my guys be thorough and look at everything themselves and make sure there's no issues, then just slap a compressor in and call it good. And then 3 days later, the store tech's all mad again because the compressor's dead. And now, we're eating labor, even though he said he already looked at it. We're eating the labor costs to change a compressor again. So where do we make any money? We didn't sell the compressor. We didn't sell any of the parts. So we sold labor that we barely make any money on. And now we're eating it. And there's 2 guys that are changing it again for free. Who lost here? The store or us? The contractor lost. So that's why it's, imperative to, put a little bit more time in here. Say if you got 2 guys 8 hours, or 2 guys 12 hours. So one guy's there for 8 hours, one guy's a helper's there for 4 hours to get the compressor in and get the compressor out. And then you got a journeyman there to, start it up, test it, check your oil pressure. You should be checking every single time you start a compressor. You should be checking voltage on a new contactor. Make sure you got good voltage. You should be checking tightness of all the electrical connections. You should be testing the safeties. You should be testing the oil pressure. So on a brand new compressor, I will let it run for like 10 minutes. I'll check the oil pressure, crankcase versus oil pump pressure, or suction versus oil pump pressure. I will check the oil pump pressure. On a Copeland, a brand new Copeland, you should have 50 pounds. If it's below 45, there's something wrong with the compressor. Something's up. You don't have enough oil in it. Something's going on. Bits are 45, 50 pounds. Sometimes you'll see them at 40, brand new. If they're lower than that, if they're in the 30s, something's wrong. Stop immediately. Carlisle's, the new ones are like 30, 35 pounds. The older ones are like 15 to 20 pounds. So Carlisle's don't have a screen in them, or they do, but it's huge and inaccessible. Basically, you have to flip the compressor over to get to it. Copeland's and Bitzers both have screens in the front of the oil pumps. So before you condemn a compressor. With low oil pressure, that screen needs to be checked and cleaned. Putting an oil pump on a compressor generally doesn't last very long. It'll last a few more months after that. In my experience, 6-7 months. But hey, what if it buys you 6-7 months? Slap an oil pump on there if that's what you want to do. That's all up to you. But when you're starting these compressors, you want to check amp draw. Make sure all 3 legs are drawing the same amps. An amp or 2 difference here or there. But if you have a high difference between, say, like L1 and L2, you have like a 10 amp difference. Okay, something's wrong here. Wiring connection's loose, bad wire. There could be loose incoming power to the contactor from the breaker, or the wires feeding the breaker from the distribution block in the rack. Those could be loose, causing problems. So you want to check voltage and amp draw on all 3 legs. You want to verify your safeties. Make sure your oil safety works properly. You want to verify your oil floats. I generally, if I'm changing a compressor with an oil float and it looks terrible, I'm changing the oil float. Oil floats are cheap, and if they're like filthy dirty, why waste the time trying to clean them? Just put a new oil float in. And then that one you can clean, and it's a backup. So brand new fresh oil float, clean sight glass where you can see everything. Set the oil float to what the chart says from Sporlan or Henry or whatever you got. Set the oil float from the chart. And then once you guys got that, then all you got to do is take that and watch it. If it keeps filling up, is it coming down the oil line? It's got a brand new float. It shouldn't be. Is the oil differential pressure too high and it's blowing the float open? I've seen that a lot. Like the oil differential, the Sporlan oil floats can't take more than 90 psi differential before they start blowing open. So I've seen guys jack up differential valves and cause issues. So make sure those differential valves are set properly. Make sure that the ORD is working properly and it's not stuck shut and causing everything to overpressurize and blow the float open. And make sure the float's set properly, or make sure somebody didn't crush the ball or drop the ball off the adjustment stem. So that's one thing that you guys need to really pay attention to, because that'll kill a compressor real quick if it's not getting enough oil or if it's getting too much oil. There's that fine spot. And then after you check your oil system, okay, the oil's good, then you're going to want to check your discharge temps, 6 inches away from the compressor after it runs for like 20, 30 minutes. Make sure your discharge temps are good, your suction temps are good. That way you're not overheating this compressor. And then overheating is the number 1 cause of compressor failures, according to Copeland. So you want to make sure 6 inches away from that compressor, you're less than like 200 degrees. If you aren't, then you need to check your suction temp coming back. And if it's a low temp rack and there's no frost on that suction header or that back of the compressor, I'll tell you right now, your superheat's too high. And you're just causing issues. Get that suction header frosted up. Get the end bells frosted up. All that means is below 32 degrees. If you're running a minus 20 rack, you should be at 0 to 5 degrees on the suction header. It's going to have ice on it. It should. That otherwise you're going to have high superheat, and high superheat makes high discharge temps. High discharge temps decrease condenser sizing. And then it just drives up compression ratios. So the lower you keep that compression ratio, the better and more efficient that compressor is going to be. Same thing with lowering the suction set points. If you start lowering suction set points, guess what? That's going to drive up compression ratio on the rack. And when you drive up compression ratio, you drive up heat. And that's going to make your discharge hotter. So keeping that suction temp up as high as you can, saturation temp up as high as you can, is going to help with the efficiency of that rack, and it's also going to help reduce the discharge temps on those compressors tremendously. So that's why you guys really need to pay attention and make sure these racks aren't floated down and they're actually floating up. So, and then first, the last thing is just verifying that everything is, cleaned up, tight. All the connections are tight. Your electrical connections are tight. Use a torque wrench, torquing screwdriver. You make sure everything is tight on all of them. Make sure your rotation's correct. Don't just slap a scroll in and not verify the rotation, because if you don't, it'll end up I've seen compressors run backwards for a while Like I found one the other day that was running backwards for a month and a half, and I got it to reset. I mean, is it going to last long? Probably not. I mean, they say they burn up right away, but it was still running. It had a discharge temp at 240 degrees and was going off an internal. When I reset it, I mean, the discharge came down to 190, but I mean, it's probably not going to last much longer than that. So that's one thing. I mean, that's a bonehead, beginning mistake to miss. So when you start up a scroll or a screw, it's imperative they go the right way. A screw will annihilate itself. I mean, you may get to bump it for a split second. If you don't see your suction and discharge pressures go away from each other and they kind of stay the same, it's going backwards. Shut it down immediately, flip the legs. That's why a rotation tester is a good tool to have. Just make sure it's a properly set up rotation tester, and it doesn't explode when you put it to 460. But I mean, testing rotation on those before you set it up. Even though you pulled the compressor apart and say it's a scroll and somebody condemned it, and you hook the wires back up the exact way it was, doesn't mean that it got flipped in the contactor or somewhere else, and that's why the compressor actually failed. So just you'll hear a scroll, it'll sound different. So just make sure it's rotating the correct way. And the other thing for recips is make sure all the recips are rotating the same way on the rack. Make sure you don't have one going L1, L3, L2, because what'll happen is those motors are going different directions. This can cause pulsations on the rack and cause it to vibrate and break lines. You don't see this a lot, but I've found a couple racks where they kept breaking lines and nobody could find anything wrong with the compressors, no vibration issues, and randomly these frequency vibrations from compressors running at different rotations were causing frequency issues, and they were causing frequency line breaks. So they were causing lines to break on the racks. So that's one other thing to keep in mind. Make sure everything's rotating the correct direction. But all right, guys, thanks for listening. Have a nice night.